Hello everyone, and welcome back to Hub360 Circuits, your go-to channel for electronics tutorial, embedded system, and practical IoT projects. In today's video, we'll be taking a deep dive into one of the most powerful and beginner-friendly Wi-Fi microcontroller boards available today, the Expressive System ESP32-C3 Development Module. This board is a compact development board built around the ESP32-C3 chip, and it brings together Wi-Fi connectivity, Bluetooth low energy, a powerful 32-bit RISC-V processor, low power operation for IoT devices, USB programming support, and onboard components like LED, buttons, and antenna support. Today, we'll be looking at the specification, features, the advantage and disadvantage, the pinout and functions, the onboard LEDs and buttons, the antenna hole you can see on the board, how to solder the pins properly, and finally how to test the onboard LED using a simple program. The ESP32-C3 development module does not come with soldered header pins, so before we can use it on a breadboard, we must solder the pins. Here is what I am doing. Now let me walk you through the software setup and the code we are using to test the ESP32-C3 development board. Before we even write or upload any code, we need to properly configure the Arduino IDE for the ESP32-C3 board. If you are not sure which port is your ESP32-C3, unplug the USB cable and plug it back in. The new COM port that appears is your ESP32-C3 development module. On most ESP32-C3 development boards, the onboard LED is connected to GPIO8. So in this test, I'll be using GPIO8 to control the LED. So here we define the LED pin as GPIO8. In the void setup, we initialize the LED pin as an output. This is the setup function. The setup function runs only once when the ESP32-C3 is powered on or reset. Inside setup, we configure the LED pin as output. This means that the ESP32-C3 is allowed to send electric signal to the LED to turn it off and on. Without setting the pin mode to output, the LED would not work properly. Now this is your loop function. The loop function runs continuously as long as the ESP32-C3 is powered on. Inside the loop, you can see digital write LED pin high. This turns the LED on. Delay 1000. This delays it for 1 second. You can also see digital write LED pin low, and this turns the LED off. and then wait for 1 second again. This creates a blinking effect where the LED turns on and off every 1 second. Now we are going to upload our code. I click the upload button in the Arduino IDE. While the code is compiling and uploading, the IDE sends the program to ESP32-C3 through the USB cable. Now that we have confirmed the ESP32 is working properly with this simple LED test, we are ready to move on to building real IoT projects and smart embedded systems with Wi-Fi and Bluetooth. The ESP32-C3 development module is a development board built around the ESP32-C3 microcontroller chip made by Espressif. It is designed specifically for IoT projects, smart home devices, wireless sensor, embedded system learning, automation systems, smart access control, and wireless monitoring system. Unlike the older ESP32 boards that uses dual-core processor, the ESP32-C3 uses RISC-V core, which is an open source CPU architecture. This makes it more efficient, more open, more secure. Now, the ESP32-C3 microcontroller comes with powerful built-in features. The clock speed is up to 160 MHz. It has a flash memory of typically 4 MB. It has a RAM of 400 KB, a Wi-Fi of 2.4 GHz. It uses BLE for its Bluetooth. Its operating voltage is 3.3 volts logic. The power input is 5 volts. It has GPIO pins of around 15 usable GPIO pins. This makes the ESP32-C3 perfect for battery powered devices, always connected IoT nodes, smart gate systems, and wireless display systems. Now, the ESP32-C3 has multiple GPIO pins that can be used as digital input and digital output, PWM, ADC, I2C, SPI, and UART. The common pins include GPIO2, which is for the general purpose, the GPIO3 is for UART RS, GPIO4 UART TX, GPIO8 for onboard LED, and then 3.3 volts power output, 5 volts power input, and ground. Some of the advantages of this module include built-in Wi-Fi and Bluetooth, cheaper than classic ESP32 boards, uses modern RISC-V architecture, low power consumption, built-in security features, native USB programming, perfect for IoT and automation, very small in size, and work with Arduino ecosystem. Like every other board, it also has some limitations, which are single core, fewer GPIO pins, no Bluetooth Classic, it works with only BLE, 3.3 volt logic only, 5 volts can damage the pins, lower processing power than full ESP32, and it is not ideal for heavy graphics or camera projects. So the applications, the module can be used in smart parking system, RFID access control, smart gate, home automation, smart door lock, wireless sensor, IoT dashboard, weather station, Wi-Fi display, remote monitoring, and so many IoT projects. In today's video, we explored the ESP32-C3 development module. You learned what the ESP32-C3 is, its specifications and features, advantages and disadvantages, pinout and hardware layout, how to solder the pins, and how to test the onboard LED. The board is a powerful tool for anyone learning IoT and embedded system. If you found this video helpful, don't forget to like, subscribe, and share. For quality ESP32 board, sensors, and electronic components, check out Hub360 Circuits. Thanks for watching. I will see you in the next tutorial.